All right, everybody, welcome to yet another OpenShift Commons briefing. As we like to do on Mondays, we like to have people from upstream projects or new products or new something to give us updates and allow us to ask any questions that we might have of these projects. And today, we're really grateful to have two wonderful folks from IBM who've been working on Istio for a long time, Linton Sun and Daniel Berg, with us to answer your questions about making sense of Istio and service meshes. So I'm going to be quiet, let them both introduce themselves and give us a presentation and a bit of a demo, and then there's room for live Q&A at the end of this. And so please, Lin Sun and Daniel, take yourself down this journey.
Great. Thanks, Diane. Okay, Lynn, if you could go to the next slide. Go ahead and introduce ourselves very quickly here. I'll go ahead and just introduce both of us, and then Lynn can talk a bit more when we switch over. So I'm Daniel Berg. I'm joined by Lin Sun. We both work very closely from within IBM Cloud on Istio, as well as all things containers and Kubernetes. We're both co-founders of the Istio project with Google, but we were there since the very beginning. Seems like, my gosh, forever now. It's been a long time we've been on this journey. We're both on the steering committee and both members of the technical committee as well on Istio. We're also in the small family of authors in this space. There's a group of us that have been authoring a set of books around Istio. Lynn and I published a book at the end of last year called Istio Explained. The nice thing about it, it's the smallest of all of them, and it gives you a pretty nice introduction into service mesh and Istio itself. And what we're going to do in this hour, we're going to take a little bit of time to explore and give you an introduction about what is a service mesh, what is Istio, but also take a look at some of the techniques that we've explored within that book of how to take advantage of and make use of Istio as a service mesh. Next slide. So first and foremost, one of the challenges, or the biggest challenge that we see with customers, is just that the ability for them to manage their microservices is fundamentally a complex problem. But it doesn't have to be complex. I mean, we've overthought some of the situations a bit too much, and some of the traditional mechanisms for handling microservices are a bit cumbersome to actually use and especially to use within a cloud or container native environment. But with service mesh, and service meshes have been introduced recently to deal with these complexities and try to avoid or remove some of the boundaries for adopting and managing your microservices. And it doesn't even have to be microservices. This is fundamentally, how do you deal with the complexities of a distributed system, specifically what you see in a cloud environment. Next slide. Can you move to the next one, Lynn?
Yes, what is a service mesh? It's on my screen now. Is it not painting for you?
There's a little bit of lag.
Uh-oh.
There's just a little bit of lag.
Should I?
Am I broken?
Yeah, should I click on one more and go back to see?
No, you're doing. No, go back to where you were. There's a little bit of lag.
Yeah, I went back already. So Diane, you could see it?
I could see it. I can hear you. I can hear you, Dan. So say something, Dan.
Hello?
Dan yep, Dan, you're good. Can you see the screen now?
Yeah, maybe his network was not.
I think he's having some network issues, so. Yeah, so Daniel might not be able to hear us. Hey, Daniel. This happens, so sounds like looks like he can't hear us either. So wherever he is, and this is the wonderful thing about being in a wonderful virtual world, things like this happen.
Yeah, it's hard because our kids are doing online school learning as well. They're using the bandwidth, and
Yep.
we can't say, we are top priority because their tasks are just as important, right?
Absolutely, yeah. So Dan, can you see
Okay.
the slide now?
I can now, and now I hear everyone.
Okay, good. Welcome back.
All right. So let's continue on.
Okay.
All right. So what is a service mesh? So a service mesh is really developed as a modern day mechanism for managing your microservices. It is a programmable framework that allows you to basically observe, secure, and connect your microservices. The key aspect of this one is it is programmable. It removes a lot of the burden that is generally required to be coded into your application, removes that out, puts it into the network, and specifically within the service mesh framework itself, and allows it to be programmed. That's a key aspect of it. Get it out of your applications and put it into the programmable framework. Next slide. So Istio is fundamentally a service mesh. So it's an open source project started, 2.5, almost 3 years ago by IBM and Google to introduce what is today known as a modern day service mesh. It allows you to connect, secure, and observe your interactions between your services and or microservices, whether they're in VMs or containers. So it is an implementation of a service mesh, and it is open source. One of the very first, if you will, one of the very first service meshes to be made available. Next slide. So I wanted to take a little bit of time just to address some of the community aspects. So if you've been following along with Istio and you've been looking at service meshes, there's really no way you haven't heard about Istio as part of within the community of the service meshes. And you've probably heard of some of the challenges that have been happening within the community. Much like any growing project, an open source project, there's going to be some growing pains. So one of the growing pains that we've had to come through is one around just ownership of the project. While we had desires and ambitions to move the Istio project into the CNCF as a third-party board or group to manage the legalities of the project, there were some disconnects in with Google as far as whether or not that is the proper target for managing the Istio trademark and legal issues. So what happened this year is that Google created an open usage commons group or board that is used to manage the trademark for open source projects, of which Istio was one of them that was moved into the Google Open Usage Commons. Now, while Red Hat and IBM were not in favor of this move, we really weren't in a position to block it either. At the same time, we started to explore adjusting the Istio steering committee. The steering committee for several years, or at least a couple years, has been largely controlled by IBM and Google. And that's fundamentally been the makeup of the steering committee, mostly because that's how it was founded. We wanted to expand the steering committee to have more diversity, limit powers and controls of the founders, and really broaden the number of participants within the committee. So over, I think it was about a 6-month period, we spent time adjusting the steering committee charter. There was a little bit of disconnect or disagreement as far as what the actual composition of the steering committee should be. But in the end, I think we came to a nice compromise, and we have a new steering committee charter that has been ratified and made available about a month ago. And we just finished the elections for the new steering committee seats, which is great because now, and I've got links in here, you can see some of the blog posts. We have a new charter, an expanded steering committee, and new members are now part of that committee. including folks from Tetrate, from Aspen Mesh, Solo, as well as Huawei. So we have definitely broadened it. And even in the short amount of time that the new steering committee has grown, we've seen some big improvements there. So all in all, Istio is growing. There's been some bumps along the way, but the community is strong. IBM and Red Hat's position is that we continue to invest in Istio, and we will continue to invest in Istio as it stands. So we are members of the steering and technical committee. We are not pulling out our investment or removing folks from the Istio community. So it's still strong, still healthy, and we're still investing in it. Next slide. Again.
Daniel, are you still waiting for the slide to show up? And he dropped off again.
Yeah.
I know. So, and what I would say to everyone, if anyone's listening, and to Lynn's son and Daniel when he gets back, is don't worry. These are the things that we can edit out of the final version of the video that we'll share on YouTube. So as long as we get the content, I'm happy with this. And this is part of, part of being in a virtual world here.
Yeah, this made me think why KubeCon, they really want us pre-recording everything just because of the network issue people might encounter.
Yeah, that's what this next week we're doing all of recording for. We've got some amazing speakers, but hey, Daniel.
Yeah, sorry about that.
I'll repeat myself again. Don't worry about that. I'll edit the final video of this. This is a live stream, but we will make an edited version that takes out the things. And so we'll just do this. I don't know. It may run faster from if you're pushing the slides, but I don't think so. So just go ahead and let's talk about Istio architecture.
Yeah, sure. So the Istio architecture, just to give everyone a quick 101 lesson around the Istio architecture. The Istio architecture is really broken down between a data plane and a control plane. So, and you can step through this, Lynn. I think there's a couple steps into this one. The control plane itself is where the framework is actually programmed, and it's made up of a single binary called Istiod. It's a change that we made last year where we simplified the management and the deployment architecture and made it a single binary to make it easier to manage. And it includes all of the key components of Istio: Pilot, Galley, Citadel, and the sidecar injector. All of that's contained within the one binary, but it's used for programming the Istio service mesh. So that's when the APIs are called or the CLI are called, you're actually updating components within Istiod. And that's installed inside of a Kubernetes cluster, and it manages the configuration through CRDs. Now, they program the data plane. And the data plane is a set of sidecar proxies that are injected into the deployments and the pods of your services or your deployments. So in this case, you have service A and service B. And the way that this works is you program the configurations through the control plane, so your API and your CLI, and it sends configuration data to the sidecar proxies to interpret how your services are to communicate. So in this case, service A needs to communicate to service B. How this works is that the sidecar proxy captures all inbound and outbound traffic, will interpret it based on the programming, and then send it on to the target service, where the other sidecar will intercept the traffic as well, do the negotiation to determine whether or not it should accept the traffic, and if so, process it and pass it on to the underlying container application itself. So this is how this is done programmatically through the control plane, and allows for zero or very, very limited changes to the application because of the way that the data plane. Next slide. Now, we've introduced into the Istio architecture this notion of gateways. And we have the ability, and the gateway fundamentally takes ingress traffic or inbound traffic coming into the mesh and allows to program that and then forward it on to one of the services programmed in here. The reason why you want the ingress gateway is that it provides the inbound access to the mesh. This is how you get into the mesh, and this is how it can control communication. So it can develop and support mutual TLS or secure connections into the service mesh and then on to downward services that are included into the service mesh. One thing to note, we've seen a lot of folks where they adopt Istio to adopt the Istio gateways initially, and then over time evolve and add the actual services into the service mesh. So it's a very common practice we've seen. And of course, there on the back end of this is the egress gateways or the outbound connections, which is a hugely valuable part of the overall service mesh, is that you want to be able to control both inbound and outbound. And what's great about the Istio egress gateway support is you can define policies for how do you target and connect to services outside the service mesh. And those policies can be written in both layer 4 IP and layer 7 URLs formats, which is really nice because you can't do that with Kubernetes alone. Kubernetes network policies can only write layer 4 policies. So very valuable, controls your exit points out of the service mesh. Next slide.
So Istio techniques.
So next slide is you.
Yeah, so I will take it over then, Dan. So we're going to talk about the Istio techniques. The first technique is Istio really have done a lot of work to simplify setup and management of the Istio control plane and the interactions through CLI. So for instance, you could do Istio Cuddle manifest apply. You can even do Istio Cuddle install and then specify whichever profile you wanted. If you don't specify, we will just install the default profile for you. So really one single command, you can get Istio installed. You can also do version upgrade easily using Istio Cuddle. So you can check out what version you have. You can do manifest Istio Cuddle upgrade to upgrade your Istio from one version to the other version. So we really spend a lot of time upstream to simplify the install and upgrade experience for our user. If you prefer not to do your own install and upgrade of the control plane, we do also offer a managed service of Istio where you would install Istio to the IBM Kubernetes service. And we would, give you the warning, and then you can basically do a one-click install to install Istio onto your cluster. Let me spend a minute to introduce our application. So Dan talked about, we wrote a book about Istio Explained, a really short book, like 70 pages. And inside of the book, we were using a application called Trade, where it has 3 services where we deploy in the stock trader namespace trader, portfolio, and stock quote. And the stock quote uses external stock services to find like the current price for different company or index or fund. It also have a DB2 service, which we deploy into a different namespace, and everything runs within the Kubernetes cluster. When we deploy our application, because DB2 was a stateful set, so we want to separate out in a different namespace, and we decided stateful set is actually relatively complicated with service mesh because the quorum establishment between the leader and members, sometimes it has interfere with mutual TLS. So for DB2, we are not injecting sidecar into DB2. When we deploy the application, we first just have the application deploy as it is without service mesh. And then you can see all the pods and services are running with 1/1, which means they're just running with their own container by them itself. And then you can see you can access the trade application. So this is everything without service mesh. So now we started to gradually introduce service mesh into our application. And the first thing we look at was secure the inbound traffic, right? We want to be able to leverage Istio ingress gateway along with the network load balancer provided by our cloud. To be able to allow user to secure access the trade application so it can access using HTTPS. As you can see, we're just creating the NLB DNS hostname for my cluster, and we are copying the credential from the NIB hostname to Istio ingress gateway configuration namespace, which happens to be Istio system, so that our ingress gateway could consume it. So in this example, we are using the credential name, which refers to the trade credential we copied from our NLB and for the ingress gateway to consume. And now any of the Istio configuration, you can just apply it using kubectl commands, like how you normally interact with Kubernetes. As you can see, we deploy the gateway resource with the secret. Now we're configuring the routing behavior on the gateway. So the gateway knows whenever the user hits /trade on the gateway, it's going to route the traffic to trade service 9080 on the port. Now you can see, we can actually access our trade application securely now through the hostname provided by our network load balancer in our cloud. The next thing we did was we want to add our services to the mesh, right? We're not just adding the gateway, secure the gateway. We really want to, adding sidecars to each of our services. So for us to do that, we added add to mesh. We are just calling add to mesh command to add each of the services into the mesh. Alternatively, you can also using automatic sidecar injector by label the particular namespace with Istio injection enabled, and then kind of kill your pod so that it would redeploy and it would pick up the sidecar automatically. So either of these approach would work, and then the ending result is what you see. The 3 of our services each would have 2/2 running, meaning the sidecar are successfully injected, and they are also successfully running within that pod. Now let's take a look. We have the sidecar running. So what benefit do we actually gain, right? So instantly we find out that we can actually observe traffic communication without any code change. So what we did is we went to visit the application, notice we still visit the secure interface, and we generated a little bit load on our services. On our application, we did a couple of trade activities, and then instantly we find out we can actually visualize what's going on within our application, like all the traffic flow among each of the services is all available to us through Kayali. So that's really impressive. Just injecting the sidecar, we gained tremendous visibilities into our microservices. The next thing we did is we want to observe, how the time are spent on each of the requests among the microservices. So we decided we're going to load up Jaeger to help us visualize that. After we made sure, we have the trace headers are properly propagated among our microservices, and then we load up the Jaeger interface, and we see all the requests on that interface, and through each of the requests, we can click on them, which is the UI you see right now, and then you can see precisely where the time are spent among the interactions of each of these services. So that's really powerful when you have problems to help you troubleshooting what might be wrong. The next thing we look at is, it's nice we were able to observe the microservices. We were able to secure the edge on the inbound traffic, but we really want to also services in the mesh. So we explored the ways Istio provide to allow us to secure communications. By default, Istio would have permissive mutual TLS enabled. What does this mean is Istio sidecar proxy will attempt mutual TLS first, and if it works, it will just own the mutual TLS. But if it doesn't work, it will fall back to plain text. So you can still have the traffic communicate, so your application can continue function. So this is great when you're onboarding your microservice to the mesh, but as you work beyond to working with your security team, have your security review, you will be asked, hey, can we actually make sure only the mutual TLS traffic are allowed? So Istio has a simple way to do that through peer authentication policy. So this is a new policy introduced in 1.5. Prior to 1.5, it has a different name. I think it might be called authentication policy. But in 1.5, this policy graduate from alpha to beta, and then you can indicate the scope of this policy. So, instance, in this example, we said, I want strict mutual TLS just for the stock trader namespace. So you could do that at mesh-wide or per namespace. You can also do that for selective application or deployments within that particular namespace. So this API is flexible enough for you to configure that. So now that we secure all the traffics, the next thing we look at is, we're not going to be happy with one version of our services. Sometimes we have to make changes to our application, and the right way to introduce changes is through different version and be able to dock launch the new version without impacting any of our users out there. So what we are looking at is we introduce trade version 2 of our trader services, and what we have is we want to dock launch it first. So if you are looking at just Kubernetes without Istio, in this case, the moment you actually deploy trader version 2, Kubernetes will round robin between version 1 and version 2. So you actually immediately expose version 2 to your user. But in this case, through Istio virtual services, we were able to config, hey, I want to have 100% of the traffic continue goes to the version 1 of the trader service because, I don't have confidence with version 2. And then you can see this destination rule just to say, I'm adding subset version 1 and version 2 so that I could potentially config some selective routes behavior or canary testing with version 2. In this example, we basically said, through the route configuration of virtual services, we are going to config the Istio ingress gateway to route the traffic to version 2 if the user are using Firefox. If users are not using Firefox, I want to default everything else to version 1 to minimize the impact. So that would allow you to kind of do testing with Firefox and see if version 2 is good. And once you feel comfortable with version 2 a little bit more, you can use canary testing with virtual services. There's a wait concept that you could potentially say, I want to adjust 20% of the traffic to version 2. Like this example says, and the 80% still goes to version 1. In addition to dark launch, header-based routing, selective canary testing, you can also do like control traffic through resilience. Like in this example, we are configuring to say, I don't want to do any retries. I want to see how my services behave without retries. And then in this example, we are changing to say, I want to do like 3 retry attempts, and for every single retry, there's a 2 seconds timeout within my 3 attempts of retry, and then the total timeout is 10. So notice I'm doing all these changes without modify any of my deployments for my app, right? So everything is dynamic in the YAML I presented to you, and then Istio is going to programmably configure my sidecar to honor the behavior I want the sidecar to behave for the retries and timeout to build the resilience. So that's really powerful. You can also do kiosk testing to introduce errors, right? Because things doesn't always go perfect. So you want to make sure your services can actually handle error. So traditionally, this typically would involve you have to make changes, code changes to your services. But with Istio, you can simply inject like delays. You can say, for how much percentage, 100% of your traffic, always introduce certain delays. Like in this case, we're introducing 90 seconds of delay, and then boom, you just apply that configuration, and then the sidecar would kind of receive the configuration and do the work for you. You can also control outbound traffic, then talk about the egress gateway. It's really powerful, allow you to configure layer 4 and also layer 7. So by default, we allow all the outbound traffic to go through, but you can simply change that with a simple change with the config map to change allow any to registry only, means only the services that are registered are allowed to be accessed from the services within the mesh. So in this example, we had to access to this external service that running outside of Kubernetes, running outside of our cloud, and we have to access it to get the current stock price for a given price quote. So we're adding a service entry to import the external services into the mesh so that the services in the mesh can access to this external services on HTTPS. You probably will run into debugging at one point because things doesn't go smooth as always. So in this example, we are showing, through Istio Cuddle, you can analyze a particular YAML file. You can actually analyze a particular namespace and your entire cluster, and it actually shows you what might be wrong. So we highly recommend you to use this command first whenever you have troubles, because it's going to help you with a lot of insight of what might be wrong. There's also a describe command that would also allow you to describe what's going on with your services, so you can check if any of these make sense. Is there any warning issues here as well? At one point, you may have to check your proxy configuration. In this example, we're checking the ingress gateway configuration to see if it has the routes we config to, to route to the trader gateway and then to dedicate to the trader services. Sometimes you have to check whether your proxy has all the latest information from the Istio control plane. So in this example, we actually display statistic from CDS, cluster discovery service, listener discovery service, and also endpoint discovery service, so that we will make sure your Envoy sidecar proxy have the latest information from Istio control plane, because you will know when it doesn't. It probably explains, the stuff you program Istio to do is not properly propagated to your sidecars. What's new in the community? I feel tremendously excited that we have been able to continue to release on a quarterly basis this year, and same as last year as well. We have been doing a release every single quarter. So our next release will be right around KubeCon North America, probably right before Thanksgiving in November. And this tremendous features of Istio with every single releases. So one of the top feature, I would highlight is Istio Kado usability improvements across all the different commands, not just the analyzer and describe. The proxy config we talk about, there was so many other commands being added. A lot of commands are graduated from experimentals, a lot of changes there. We realized some of our users been complaining about downtime during upgrade. So Canary upgrade of the control plane component have been introduced to help minimize the downtime, so reduce that downtime to 0 during upgrade, and also allows you to fully control and testing the new version before you fully switch over, so you can do fully control your upgrade. You have kind of like Istio leveraging, Canary for our own control plane ourselves, so we can provide a better experience for our user. Similar as how we recommend our user to do canary testing, like what I showed, to do trader, dark launching, selective route, header-based routing, and 20-80% testing. So we're introducing the power of canary to our own control plane. We are also working very hard to get the VM to be able to onboarding services on the VM, mesh expansion, to allow mesh to be expanded on virtual machine, and also multi-cluster. We recently are working on consolidate the replicate control plane model and also the shell control plane model into one single multi-cluster model to help our user, so that user can based on one single model and decide whether they want to run control plane in each cluster, or whether they just want to have one single control plane, whether they have single network, flat network, or whether they have multiple network. But it's one single deployment model based on what they need. They can select different configurations. So we're trying to working hard in the community to drive that to beta, so that users feel more comfortable using multi-cluster and using services, running services on the VM, bring to the mesh. Some of the key focus area for the IBM and Red Hat team in the community is external Istiod, as we're showing on the diagram on the right side. We are standardizing a model within the community that allows the mesh operator to operate Istio control plane outside of the data plane cluster. So in this example, you can see, the users, the mesh admin and the mesh users who are operating their services in the mesh, they can continue working with Istio as they would today, except, they don't have to worry about managing, installing, upgrading the Istio control plane. This also enable us as a cloud provider to be able to provide Istio as a service to our user. So it's a win-win for us and also for our user as well. We're also focusing on multi-cluster and user experience improvements, and also install, upgrade, and configuration improvements on consistent API to reduce the upgrade downtime for our user, to standardize our application removal process for our users so that users are more informed. When we make changes in upstream, we also standardize process to promotion features from experimental to alpha to beta to stable, because we heard a lot of complaints about our user stability of the project. So these process to streamline, how we want to standardize different features in different stage between alpha beta. It's going to tremendously help us as a community and also help our user by having clear clarity on each of the features. With that, I would like to share a demo that on external Istiod. Bear with me as I bring up the demo. So what I would like to show you guys is then here. I'm going to show you external. So we're going to show external Istiod, and in my environment, you can see I have a management cluster that runs external Istiod. It also runs Istio by itself, just to manage like the inbound traffic mainly. So what you are seeing is the Istio by itself in Istio system to help manage the access to external Istiod, which I deploy in Istio 2 namespace. The reason I do Istio 2 is I envision we're going to deploy like hundreds of Istio, so I want to name it with a unique identification ID. As you can see, I'm deploying my cluster with just pilot enabled and nothing else, right? Because I want to have the control plane running on the management cluster. On my remote cluster, you can see I'm not having pilot running, I'm not having the control plane running. I have the base running, which is primarily just the customer resources, the service accounts for Istio. I have the Istiod remote, which is just the webhook configuration, so that it can still do, webhook validation. I'm mutating webhook to inject the sidecar. I do have the ingress gateway running on my remote cluster on the left side.
Lin Sun, could I ask you a favor? Could you make the font a little bit bigger for us? Some of us are having a hard time reading, if possible.
Yeah, because I recorded this.
Okay.
It's going to be a little bit harder to.
That's okay. Then send me the link to the video afterwards, and then I can incorporate it. But
okay.
Yes.
Yeah. Gosh, I did improve the font size. I'm sorry, it's still not big enough.
That's okay. Go for it. Sorry to interrupt.
Yeah. So as you can see on my control, data plane cluster, I have Istio ingress gateway running. I did also deploy promises, but it's just to allow you to get some statistic data, which I'll show later in a bit. So we're going to deploy the famous booking for application, and I have automatic sidecar injection enabled in this default namespace we are deployed into. So as you can see, I assume you guys are familiar with this application, so you can see, it's being running. the automatic sidecar injector is working, even though I don't have the Istiod running in my cluster. Istiod serves as a webhook server for the sidecar injector. So for me to access the Booking.info application, we're going to expose the product page onto the Ingress Gateway. As you can see, I'm running Ingress Gateway on 128.3, and all my pods have also reached running now. So this is just generic Booking.info. You got like 3 versions of the reviews deployments, and they have different stars, so it's just round robin without any routing traffic control in place. So Kubernetes just do 33% for each of the versions. So what we're going to do next is we're going to test sort of like what we talked about earlier, right? We want to do request-based routing based on the browser and or header. In this case, we're going to use end user JSON. In this case, that we want to say, when JSON logs in, we want to route the traffic to version 2, and for everything else, notice I'm having a problem now, right? The product review are not loaded. What is going on? Remember we talked about analyzer command. So what I'm going to do is analyzing my default namespace, just asking Istio what might be wrong. Look, it actually shows me, I'm referencing these subsets with host. However, I don't have a destination rule because I just didn't like to deploy things without necessity. So what we are doing is deploy the destination rule for reviews, which is going to set the subset for us. So now if I go back to refresh, you can see, I can get the review version 1, which is no stars. Now when I log in as JSON, I can always get to version 2, which is black star. So it's behaved exactly what I programmed Istio sidecar to do. What we're going to do next is actually to see some of the permissions data. So we talked about earlier, I actually have permissions running in my data plane. So we're going to try to launch the permissions dashboard. So as you can see, this is just a typical permissions dashboard. Well, it has tremendous amount of data. You can actually search for like all the Envoy statistics. You can search for all the Istio statistics. Like you can do agent info. You can also do like error code, for instance. Like in this example, I can do scrap failure total. So all that statistics are available to you. But the most important thing I want to highlight as part of this demo is, I'm not actually running my control plane in my cluster. I have someone else providing the control plane management for me, so that I don't really have to worry about, it still has a new version, it still has a new secure patch, somebody else is going to help me to install and upgrade the control plane for me. So with that, I think that's the end of the demo. I just want to give a quick mentioning of our book. And if you scan this QR code, you could just take you to the book and where you can register and read it. If you're interested to learn a little bit more about Istio, certainly you can reach us on GitHub and Istio Slack as well. So Diane, I want to send back to you for questions.
Yeah, I guess now is a good time if we have any questions to go ahead and ask us. I did want to just call out one point. I know some folks might have had trouble seeing the demo, but What's really important about that demo is that it's new technology and new approaches that we're looking at taking advantage of in the IBM product suite, in the IBM cloud specifically, for how we introduce and manage Istio. And being able to decouple the control plane from the data plane, we believe not only does it improve our ability to manage it, but we also feel that it's more secure and a better option for our customers, because now the control plane won't run in the same cluster as the data plane. So we can do more in regards to securing that Istio service mesh.
Yeah, that's a great clarification.
So I guess there was a question earlier. I was just looking at the chat, the group chat, and the question came up. Peter Larson asked this: is how is the communication between the sidecar that does TLS termination and the container with the app secured and / done? And Peter, I'm assuming you're asking specifically about the gateway and how the gateway communicates or provides secure communication back into the service mesh. So first off, when you use an Istio gateway, the gateway is basically a standalone Istio sidecar, which is an Envoy sidecar. So you can program that gateway to do secure communication, whether it's TLS or mutual TLS. You can program it to accept both types of authentication. And that's set up and configured as part of programming the gateway. And you can have it terminate, which is the default mechanism. So it would terminate that call. And then what it will do is it will re-encrypt with a new key that is used for mutual TLS within the service mesh. So it's actually not the same key that you're going to use to communicate from outside the mesh to the gateway. That is one key that needs to be programmed and configured as part of the gateway. And then the gateway will then use the internal Istiod control plane to generate the proper mutual TLS key that's going to be used for communicating within the mesh. And then it will communicate via sidecar to sidecar within the mesh to the other target service. So it basically does a re-encrypt at that point and does another mutual TLS communicate. This is why you need a gateway, by the way, because if you didn't have the gateway, there would be no way to program a mutual TLS communication directly to a service in the mesh. It's not possible. You have to go through the gateway because there's no way to program that external communication as a mutual TLS directly with a member that's not in the mesh. So you have to use the gateway to do that. Does that answer your question, Peter? Oh, I see, Peter. If you're looking at the chat, Lynn, Peter had from the sidecar to pod app. How does it encrypt? So this is using. So again, this is when it comes in from the gateway. It will terminate the communication at the gateway. And then the sidecar, the Envoy proxy, will re-encrypt using the certificate from Citadel that's in the Istio control plane to establish the communication to the target, in this case, pod app, I guess is what you've called it, a target service within the mesh. And then that negotiation happens between the two sidecars using the service identity. So it's the. Go ahead, Lynn.
Yes. So Peter, I'm not sure if what exactly you are referring to. If you're referring to from your app container to the sidecar running in the same pod namespace, that traffic is normally not encrypted because it's within the same pod namespace and networking. And if you're referring to, how that service A sidecar encrypt the traffic to service B sidecar, so it still handles that for you by upgrading that connection to mutual TLS for you. And Okay, so you are referring to the prior. Okay, yeah, so that traffic was not encrypted if it's the same pod namespace just within service A.
I guess there's another question here. There's something. Will you be able to demo how this works in OpenShift with TLS if you have time? How this is. Well, we don't have time, but fundamentally, it's no different. It's no different than what Lynn had shown, at least through the slides, of enabling mutual TLS communication. The way in which mutual TLS communication is enabled and used is the same within OpenShift and as well as if you're installing and running the community. What is different is, and maybe this is what you're touching on, is the setup and the use of the Red Hat service mesh, which is based on Istio. Now, the Red Hat service mesh you have to you install through a operator, and you install that, and basically what you have to do is you have to designate member projects that participate in the Red Hat service mesh. And what that does is fundamentally under the covers there are CRs that will go through and program network policies that will ensure communication from the Istio control plane to the set of projects that you've introduced in there. So you could support multi-tenancy within the same cluster. So you could have multiple Istio control planes controlling only a subset of projects within the OpenShift environment. But outside of that, once you've done that setup, then the rest of it, programming is identical as it is in the community. As far as setting up mutual TLS communication, all of that's the same.
Yeah, this is the best part about having this feature in upstream. So Red Hat Service Mesh would just be consuming what's in upstream when they are ready to.
All right, and Diane, it sounds like you're. I don't hear you, by the way. If you're trying to speak.
Yeah, we can't hear you. And I think that might be all the questions.
I don't see any others.
Yeah, she said we ran out of time.
Hey everybody, it's Chris. I think Diane is having some technical difficulties, so and bandwidth issues. So yes, we've run out of time, and I think that does cover all the questions we've had. So thank you very much, Daniel and Lynn, for joining us today, and we look forward to seeing you on an OpenShift Commons briefing here in the near future. Please check out the streaming calendar to learn more. Thank you.
Thank you.
Yeah, thank you. It's our pleasure.